Okay, so 1.6. Well, we started 1.6 last class. We're picking up where we left off. We're looking at solving radical equations. First step, if necessary, isolate one radical to one side of the equation. Second step, raise both sides of the equation to the power of the index of the radical. So in other words, if you have a square root, you're going to raise both sides to the power of 2. Cube root, raise both sides to the power of 3. The fourth root, raise both sides to the power of 4, and so on. So you raise both sides to the power of the index of your radical. All right. So step 3, solve the equation. And if a radical still exists, then we're going to repeat steps 1 and 2. So that's going to be key. If you have another radical still a part of your equation, you go back to steps 1 and 2 to get rid of that radical. Then the last step is to check your solutions. That is a must when you're dealing with these radical equations, because we have to manipulate the equation in order to be able to solve it. And especially when you're raising both sides to an even power, you change or you alter the equation in such a way that even if you do everything correctly, it's possible to come up with solutions that may not be actual solutions. So you have to check. Notice I haven't emphasized checking your solutions. I always made it an option if you want to check your solutions. That's always the end step of your process. When you're dealing with radicals, that is a must. You have to check your solutions. All right, everybody good with the steps before we actually get to a problem? Let's scroll up. All right, so our first equation, square root of 2x minus 1 plus 2 equal to x. So notice that plus 2 is not under the radical. All right, so step 1, we want to isolate the radical. In other words, we want to get the expression with the radical on one side by itself. So I will subtract 2 from both sides. 2's cancel. That leaves us with the square root of x, square root of 2x minus 1 equal to x minus 2. All right. Could have left that. Next step, we're going to square both sides so that your square and square root will cancel. Let's see something in chat. Why is it x minus 2? Because we subtracted 2 from both sides. There's someone on chat that asked why is it x minus 2? So we subtract 2 from both sides. So that's this result right here. Now they weren't like terms, so it's not like I can actually combine them. You know, it can't subtract 2 from an unknown, so that's why it's just x minus 2. All right. So now we're going to square both sides, and the square and the square root cancels, leaves us with just 2x minus 1. Then on the right, I have x minus 2 squared. So when we go to solve, be careful. What you cannot do is square each term. Because of that minus sign, you're actually squaring a quantity. So that's what we have here on this right side. Let me erase some of this stuff. All right, so that's what we have here on this right side. We have the expansion of x minus 2 times x minus 2. You know, you FOIL out x times x times -2, -2 times x, -2 times -2. And that gives us this quantity right here. All right, somebody said something in the chat. Is there exponent 2 because... No, the exponent is 2 because the square root of x is the same thing as x to the 1/2. Just like if you had a cube root of x, it's x to the 1/3. So you normally see an index there. If you don't see anything there, they assume you know there's a 2 there. You know, anything else, the fourth root will be x to the 1/4 and so on. So any other radical will have an index there. If nothing is there, then they assume you know there's a 2 there. So that's why we squared both sides. Once again, if there was a 3 right there, then we would have cubed both sides, raise both sides to the power of 3. See if I can just keep that. It won't let me. Okay. All right, so now that I have this expression right here, this equation, we have 2x minus 1 equal to x squared minus 4x plus 4. You have a quadratic equation, so you want to set one side equal to 0. So I will subtract 2x and add 1 to both sides. 2x's cancel, 1's cancel. And so now I have 0 on that left side. And that'll give me this expression right here. X squared minus 6x plus 5 equal to 0. So once again, once you have this quadratic equation, we talked about that last class, I'm going to set one side equal to 0. So I subtracted 2x and added 1 to both sides. All right. So now I decided to factor. X squared minus 6x plus 5 is equal to x minus 5 times x minus 1 equal to 0. Don't forget, if you do not want to factor or you're not comfortable with factoring, you can always use the quadratic formula. It will give you the same result. Quadratic formula will give you the same result. Setting both parts equal to 0, it's x minus 5 equal to 0, x minus 1 equal to 0. So I get the two solutions, x equal to 5, x equal to 1. All right, questions? Any problems before we go to check?
I had a question.
Yep.
On step number 2, where you said square both sides, I'm kind of confused on that because I didn't see the square on the other side of the equation on that, like on the first step of 2. Like I didn't see that you squared x minus 2.
All right, so let me make sure you say, let me get my, okay. So you're saying right here.
Mm-hmm.
Okay, so so let me make sure you ask you the right question. So are you asking me why did I square both sides?
No,
So you're okay with the reason as to why I squared both sides?
Yeah, actually, I think I answered my own question.
You sure?
Yeah.
Okay. All right. Anybody else before we look to check to see if our solutions are correct?
Professor Tucker,
Yes, sir.
I'm not trying to teach the class,
Okay.
but it would help probably if you say to eliminate the radical.
What did I say?
I think that's where people got confused at.
Well, what did I say?
I can't recall what you said, but
Oh, yeah. So,
I think people, they might be saying they don't understand you have to eliminate the radical.
I thought I said that. That's why I was asking you, what did I say? Because I said something in order to get from here to here.
So
You see what I
You
mean?
square the radical.
So, he said I said square the radical. So, if I didn't say it, then I apologize. But yeah, so what we're trying to do is to get rid of this radical so that we can have access to the x. The reason why we did it, or the reason why we squared, is in order to do that. So that's what I was mentioning over here. We talked about the cube root. In order to get rid of the cube root, you would cube, or if we have the fourth root, then in order to get rid of the fourth root, you raise to the fourth power. So, and also just reinforcing the idea, because I know somebody had asked, that if you don't see anything there, they assume you know that there's a 2 right there. And so that's why we squared both sides, so we can get rid of the radical. How did you get x minus 5, x minus, so I got this by factoring. And so that's when you have to look at your signs. If the second one is positive, it means both of them will be the same inside of your parentheses. This one lets us know to use both minus signs. So that's how we got negatives in both of our parentheses. Then x squared, the way we get x squared is by doing x times x. So that's why we have that. And then you're looking at, how do we get 5 in the back? Well, we need our factors of 5. Well, the only factors of 5 that we have, which is 1 times 5. And so if we were to put those in here, right there, then we can check it and make sure that we get -6 in the middle. So you're talking about -5 times -1 will give you a +5. -5 plus -1 will give you a -6 in the middle. And so that's how we got that factorization. Once again, though, if you're not comfortable with your factorization, you can always do your quadratic formula, which will give you these 2 solutions. You do your quadratic formula, it will give you those 2 solutions. All right. Yeah, Mr. Cole, I think I said to get rid of the radical. I don't think I said eliminate. I believe I said to get rid of the radical. I think that's what I said. Anyway, but yeah, don't ever feel like you're teaching the class. If you have a suggestion, feel free to drop that in there. You know, you're good to go.
thank you. I learned from you.
Ha, you funny, man. But yeah, always, if anybody, and that's that's for anyone, because I could not say something that may register with somebody else, and keywords here and there can make all the difference in the world. So if anybody ever have a suggestion, feel free. But and I wasn't challenging him. I was just wanting to know, what did I say in order to get to a certain step. So I wasn't challenged. So I don't want anybody to feel like, oh shoot, if I say something, he's gonna challenge me. No, I wanted to know, what did I say? You know what I mean? So that's all that was about. But me and him, we go back like bussies. I had him in the previous class, so we good to go. So this is us checking it now. Check both of our solutions. We have x equal to 5, x equal to 1. You go back to your original equation, which was the square root of 2x minus 1 plus 2 equal to 5, equal to x, excuse me. So I plug in 5 where I see x for the first one, and then do the work. If it comes down, check out to give us, a true statement, then it is a solution. So notice we plugged that 5 in there. 2 times 5 minus 1 gave us 10 minus 1 under the radical. 10 minus 1 gave us 9. Square root of 9 is 3. 3 plus 2 is 5. So you see that worked out for us. 5 equal to 5. On the right side, though, we have x equal to 1. Plug in 1 in both spots that we see x. And you see when you do the work, you come down to 3 equal to 1, which is not a true statement. So x equal to 5 is our only solution. All right. Make sure we're okay with the check. Make sure we're okay with anything that was said before we do another one. All right, so are we good? Scroll up. All right, the next one. Square root of 3x plus 1 minus square root of x plus 4 equal to 1. So this time we have more than one radical. All right. Step 1 is to get one of those radicals to one side of the equation alone. Doesn't matter which one you move. If you do everything correctly, you still come up with the same solution. The easiest one to move is this one because it has the minus sign sitting right there. So if we add the square root of x plus 4 to both sides.
Hey, Mr. Tucker, can you go up for
result.
like a quick second?
Right here or how far?
Right there. Just like 1 second. Yeah, right there's good. I just needed the top one on the right.
Okay.
All right, you're good. Thank you.
No problem. All right, so this is where we are now. We added the square root of x plus 4 to both sides of the equation. It cancels out on the left. And on the right, we have the square root of x plus 4 plus 1. And I always try to warn, make sure you don't extend that radical to that to be over that plus 1. Any problems? All right, so the next step is to square both sides. So if we square on the left, that will eliminate the radical. I do all right, sir? You know I got to get you right. So square both sides will eliminate the radical on the left. And then on the right, we're going to square that binomial. So don't forget, though, what we cannot do, and the reason why I left it like this is because we're going to go through the process. What we cannot do is square both pieces and then move on. You're actually squaring an expression. And so we're going to have to do our FOIL in order to expand that out. All right, somebody in the chat, could you scroll back up to the original problem? Didn't get to write it down. Yep, that's the original problem right there. Not a problem, not a problem. And so this is where we are now. Make sure everybody's with us. All right. So when you square both sides, we already talked about how it cancels out the radical on the left side, but then on the right side, we have to expand out this expression. So we have the square root of x plus 4 plus 1 times the square root of x plus 4 plus 1. So now we'll FOIL it out or do our distribution, binomial distribution. So it's going to be the square root of x plus 4 times the square root of x plus 4, square root of x plus 4 times 1. Then we have 1 times the square root of x plus 4 and 1 times 1. So let me erase some of this stuff. This will be that expression once you expand it out. So with that first term, square root of x plus 4 times the square root of x plus 4, don't forget how that works. If I have the square root of 2 times the square root of 5, that's going to be the square root of 10. I just multiply what's under the radicals. And that's what we did here. X plus 4 times x plus 4 is x plus 4 squared. So that's all we did there is we multiplied what was under the radicals. All right. Then square root of x plus 4 times 1 is just square root of x plus 4. 1 times the square root of x plus 4 is just square root of x plus 4. And then 1 times 1 in the back is just 1. All right. So before we go to the next step, questions on how we got here. We FOIL or use the binomial distribution or FOIL out.
Can you re-explain it again?
You just multiply the square root of x plus 4 times the square root of x plus 4. That gave us this right here. And then we have, oh, I lost my plus sign. Then you have square root of x plus 4 times 1, which is just this. Then 1 times the square root of x plus 4, which is this one. And then 1 times 1, which is what's right here in the back. So we're doing our binomial distribution. Square root of x plus 4 times square root of x plus 4 gives you the first term. Square root of x plus 4 times 1 gives you the second term. 1 times the square root of x plus 4 gives you the third term. And 1 times 1 gives you this fourth term. Make sure we are okay. I said something in the chat.
Hold on, I'm lost at step 3 when you multiply the both square roots because you have to square them. I don't understand that part. Right
So you just multiplying what's under the radical, like I did right here. Oh, I didn't mean to erase it. That's all good. So you just multiply what's under the radical. When I have x square root of x plus 2, square root of 2 times square root of 3, the process is just you multiply what's under the radical. So that'll give you x square root of 6. I keep wanting to put x in there. That would just be the square root of 6. So when I look at the square root of x plus 4 times the square root of x plus 4, I'm just multiplying what's under the radical. Well, x plus 4 times x plus 4 is just x plus 4 squared. And that's all that this is right here. Just x plus 4 times x plus 4. So we multiply what was under the radical. Does that make sense?
Yeah, I got it. That makes sense.
Okay, cool. So somebody else said something in the chat. What are you doing with the left? We're not doing anything with the left right now. I'm just simplifying what's on the right. We're going to come back to what's on the left. All right, so we'll come back to what's on the left. So after you distribute it, we have this expression right here. Yeah, this expression. So what we can do is simplify because we can combine the like terms. There's a 1 that's in front of each one of these. When you don't see anything, remember they assume that you know there's a 1 there. So what do I mean by that? If I can get this to erase like I want, there we go. Just like when you have y, they assume you know there's a 1 in front of the y. If you have a, they assume you know there's a 1 in front of the a. So they assume, you know, there's a 1 in front of each one of these terms. So you can add them together and get the 2. So let's do this. So they come together and give you this. This simplifies to just give you these two terms because the square and the square root will cancel. That square and square root cancel and gives you x plus 4. The two terms in the middle, or the two expressions in the middle, add together to give you 2 square root of x plus 4. And you still have that 1 in the back. To finish off the simplifying, you have a 4 now and a 1. 1 plus 4 gives you this 5 back here. So that would be the most simplified way of representing that equation. So we have 3x plus 1, which is on the left, x plus 2 square root of x plus 4 plus 5 on the right. All right, any questions before we go any further? Questions on the simplification? This process right here. All right, and scroll up. All right, so notice that we have a radical that still exists. So we're going to have to isolate the radical once again. Remember the steps. Go back to your steps. It says that if the power of the index of the radical, no, back here in step 3. If a radical still exists, then we want to repeat steps 1 and 2. So we have a radical that still exists. So we have to go back and isolate the radical. Someone says something in the chat. The 5 came from 4 plus 1. Yeah, so that's how we got that 5. All right, so we want to isolate the radical. There now. So we're going to subtract x and subtract 5. Remember, we want to get this by itself. So we're going to subtract x and subtract 5 from both sides. X is canceled and 5's canceled on the right. That leaves us with that expression, 2x minus 5, because 3x minus x is 2x. 1 plus negative 5 will be negative 4. All right, questions? All right, so now you need to square both sides. Do this. And I see somebody in the chat. I'm coming in a second. Trying to erase some stuff so we can walk through it. All right, so chat. Okay, cool, cool. That's good. All right, so we're going to square both sides like we did before. Remember, your goal is to get rid of or eliminate this radical. And so we're going to square both sides. Now, at this point right here, just in case anyone saw, I have a 2, a 4, and a 2. I actually could have divided everything by 2 to simplify the equation. I'm not doing that because there's something I want to emphasize in the next step when we go about squaring. But if you saw that, then always feel free to do so, but you don't have to. Once again, I'm doing it because I want to emphasize, not doing it because I want to emphasize something in this next step. So we already know what we should do here. That's an expansion of our binomial distribution. So we're going to square 2x minus 4 and have 2x minus 4 times 2x minus 4. Now here, this square needs to be applied to the square root, which canceled that out, but it also needs to be applied to the 2. So this is a scenario that you could see, so be careful with it. You do have to square the 2 that's on the outside of that radical, and you have to square that square root. So what's going to happen is we'll have 2x times 2x, which will give us 4x squared. 2x times negative 4 is negative 8x. Negative 4 times 2x is negative 8x. Negative 4 times negative 4 is 16. Combine those like terms, that'll be 4x squared minus 16x plus 16. Then here we can distribute, that'll be 4x plus 16. And that gives us the bottom result. 4x squared minus 16x plus 16 equal to 4x plus 16. All right, questions before we go to the next step? Make sure we're okay. All right, so we want to set one side equal to 0. So what I'm going to do is subtract 4x and subtract 16 from both sides. So 4x minus 4x will cancel. 16 minus 16 will cancel on the right. But also recognize that 16 minus 16 cancels on the left as well. And that leaves us with 4x squared minus 20x equal to 0. All right, any questions? All right, so we can factor now. 4x, I factored out 4x from each term. So that's 4x times x minus 5 equal to 0. Set each part equal to 0. And your result would be x equal to 5 and x equal to 0. So, to solve it, we divide both sides by 4. And here, add 5 to both sides. All right, any questions? All right, so just like before, we have to check them. Our original equation, square root of 3x plus 1 minus square root of 4 equal to 1. And so plug in 0 where you see x, and then plug in 5 where you see x. See, the first one comes down to give you -1 equal to 1, which is not true. Then the second one, the one where we have x equal to 5, see, it comes down to 1 equal to 1, which is true. So that's our only solution. All right, any questions? Got at least one more thing to talk about before we close out today. All right. So radical equations of the form of x to the m over n equal to k. All right. So if m is even, we're talking about the top number of your exponent. So we have an exponent that's in a fractional form. So we're talking about if your top number of your fraction is even, first thing you do, notice that we're going to raise both sides to the reciprocal of that fraction. But because it's even, we have this plus or minus that's involved, which will give us two solutions. All right. And then on the right side of that, if m is odd, we're still going to follow the same process of raising both sides to n over m, the reciprocal of the fraction. But you will only get one solution. You will only do plus or minus if your top number of your original exponent is even. All right, questions, any questions? Before we try this out. All right. So just to emphasize or re-emphasize the relationship of having a fraction as an exponent, always remember that the top number is your power, the bottom number is your root once you apply it. So it doesn't matter which order you do it in though, just remember that the bottom number is going to be your root, the index of your radical, top number will be your power. All right, someone asked to scroll up real quick. I don't know if that's enough. That's what you needed. Or if you needed more, well, that's pretty much it. All right, so they're with this. All right, so if I look at 8 to the 2/3 power, the top number is my power, bottom number is the index to my radical or my root. So I can either take the cube root of 8 and then square it, or I can square 8 and then take the cube root of it. It doesn't matter what order you do it in, as long as you use those two applications. Where it may come into play is if you're doing it in your mind or in your head, and you have different situations will bring about different familiar numbers. So if you take the cube root of 8, that'll be 2, and then 2 squared is 4. Or if you square 8 first, that'll be 64. and then take the cube root of 64, that'll still be 4. So it doesn't matter which order you do them in, as long as you remember that the top number is going to be your power, the bottom number or denominator will be your root. All right, questions on the application? All right, so let's look at the first one. We have 3x to the 3/4 power minus 81 equal to 0. So we want to isolate x to the 3/4 power, so we can use the method we just finished talking about. And also take note that we should only get one solution because our top number, our m, is odd. Okay? So the first thing we'll do is add 81 to both sides. So that'll give us 3x to the 3/4 equal to 81. Then we'll divide by 3. 3's cancel. And that'll give us x to the 3/4 equal to 27. So before we go any further, questions? Let's send something in the chat. All right. Any questions before we go past this point right here? All right, so now that we have this x to the 3/4 equal to 27, we will raise both sides. I'll go purple. Raise both sides to the 4/3 power. So now that we have this relationship right here, whenever you're raising a power to a power, you're multiplying your exponents. So that's what happens here. And whenever you multiply reciprocals, that's going to simplify to give you 1. So that's why we're doing that. You take the inverse or the reciprocal of the fraction and raise each side to that. All right. So now looking at the 27 to the 4/3 power. So the 3, got a cube root of 27, and then we were raising that to the 4th power.
I only had my Instagram a year and a half. How long you had yours?
Was that to me or hello?
Sorry.
Oh, you good. You're good. All right, so the cube root of 27 is 3, and then 3 to the 4th power will give us 81. And that'll be our result. All right. Questions before we try it again? Do at least one more time. All right. Let me erase some of this stuff. This time we have x to the 2/3 power minus 3/4 equal to negative 1/2. So this time our numerator is even, so that means we should get 2 solutions. Remember, whenever our numerator is even for our exponent, that means we should do plus or minus, or have a plus or minus scenario at the end of our processes. At the end of this process, I'll say it like that. So we need to isolate x to the 2/3 power first. So we will add 3/4 to both sides. All right. So that will give us x to the 2/3 equal to 1/4. The way that'll happen is, we got to add these two fractions. Only way you can do it, though, is you got to have your common denominator, so don't forget that. So we multiply top and bottom by 2 in order to get a fraction with the denominator of 2. Go ahead and add the 3/4. So that'll be 1/4, and that's where the 1/4 came from. All right. Questions before we look at the next piece? So we have x to the 2/3 equal to 1/4. All right, so I'm gonna say something in the chat. This is starting right here. This one ended right there. The first one ended right there at x equal to 81. All right. So raise both sides to 3/2. Remember, we need to do that because when you raise a power to a power, you multiply them, and multiplying a fraction by its reciprocal will turn it into 1, and that'll cancel that out. Do the same thing here. 3/2. All right. So left side cancels out to just give us x. And on the right side, I have plus or minus. Remember, we already knew that we were going to do that. And the denominator is 2, so we do the square root of 1/4 raised to the 3rd power. Square root of 1/4 is 1/2. Then 1/2 cubed is 1/8. So it's plus or minus 1/8 as our solutions. Questions? Any questions? All right, everybody good? We look at this last thing that connects us to these radicals. All right. Next thing we're going to look at, last thing we're going to look at today are equations in quadratic form. So what do we mean by an equation being in quadratic form? If I have, we go back to our regular quadratic form, a squared plus 5a plus 7 equal to 0. So what we have here is that we have a here, and then it will be a squared. So whenever you have your term here and then your term being squared in the first, or as your leading coefficient, that's considered being in quadratic form. So when I look at x to the fourth minus 8x squared minus 9 equals 0, I have x squared here, then x squared squared in the first term. So once again, when you have your term in the middle, and then for that leading coefficient is that term being squared, then that is considered being in quadratic form. So the reason why that is important is because you can rewrite the equation. If we let u, it's called u substitution, you let u be equal to x squared in this case, whatever's being squared, x squared. And so I have u squared minus 8u minus 9, and that helps me to solve the equation in a more simpler way, in a way that I'm used to dealing with, which is the quadratic equations. And we can go from there. So once again, if an equation is in quadratic form, we have our term, our middle term, and then in that leading term is that term being squared. Once again, whether it's a and then a squared or x squared and then x squared squared. If you have that type of relationship, that's your equation being in quadratic form. All right. So I let u be equal to x squared, giving us u squared minus 8u minus 9. And I factored it once again. If you're not comfortable with factorizations, you can always use your quadratic formula. Well, factoring this gives us u minus 9 times u plus 1. Set each piece equal to 0, u minus 9 equal to 0, u plus 1 equal to 0.
Professor Tucker,
Yep.
I got a question.
Mm-hmm.
Your center term with 8x, can you automatically assume that your u gonna be 8, that x to the second by looking at your center term?
Well, you can, but you still have to see this x squared squared. You still would have to see x to the fourth.
Okay.
In the front. If you didn't see, let's say you saw x to the fifth, then it's not in quadratic form. You see, so you still have to see x to the fourth. You have to see this middle term squared in the front. So yeah, hopefully, yeah, okay. That I was about to say, hopefully that answered your question.
I just can't go by that center term.
No, it has to be both. You have to look at both of them and see to be able to see if that relationship is there. Yeah. All right, so we solved for u, but don't forget we didn't start off with u, so we can't write our answers to be 9 and -1 because our original equation had x squared in it. So you go ahead and put the x squared back in there. So you have x squared equal to 9, x squared equal to -1. Now if you take the square root of both sides in order to get rid of the square. And don't forget, whenever we take the square root of both sides, you do plus or minus. And that'll be plus or minus 3, plus or minus I. Don't forget, whenever you take the square root of a negative number, I is involved. But in this case, all we have was -1. So that's just the square root I mean, that's just be I plus or minus I. So we have two real solutions and two imaginary solutions. All right, before I scroll up, someone's asked me to scroll up. Any questions on getting to this point? All right. I don't know how far you need me to scroll up. That's the original equation. All right, not a problem. So before we try this one more time, questions on what we did? All right, so we have 5 x to the 2/3 plus 11 x to the 1/3 plus 2 equal to 0. So once again, we have a quadratic equation, a quadratic situation, or an equation in quadratic form. When we notice our middle term is x to the 1/3, and our first term is x to the 1/3, it's 5x to the 1/3 squared. So that x to the 1/3 is what's being squared to get x to the 2/3. All right, so let u be equal to x to the 1/3. So that'll be 5u squared plus 11u plus 2 equal to 0. Factor that, that'll be 5u plus 1, u plus 2. Once again, if you want to use your quadratic formula, you can. So set each part equal to 0. 5u plus 1 equal to 0 will be u equal to negative 1/5. And then u plus 2 equal to 0 will be u equal to negative 2. All right, so before we finish this off, questions on how we got here. So don't forget, these are not our solutions. They're just going to help us get to the solutions, because u is not what we're solving for. X to the 1/3 is what we substituted in for u. So we put x to the 1/3 back in there. And that's what we're looking at. X to the 1/3 equal to negative 1/5. X to the 1/3 equal to negative 2. So here, just re-emphasizing that x to the 1/3 is the same thing as a cube root of x. X to the 1/3 is the same thing as cube root of x. So if I want to solve for x, I would cube both sides to make the cube root, and the cube cancel for me. Or the x to the 1/3 will cancel out with that cube. And so cubing negative 1/5 would be negative 1/125. And cubing negative 2 would be negative 8. Those would be our two solutions. All right. Questions? Any questions? All right. So this is where we'll stop today. Next class, we will get to absolute value equations. If you have questions, always feel free to email me. Don't forget, before we close out the chapter, we will have at least one review day. If not more, we'll see how that goes. But I will set aside at least one day in which, you know, I won't go over anything new. We'll just answer whatever questions you guys have. And if that, you know, runs over or bleeds over into another day, we can do that. But, you know, that will always all be dependent upon you and the questions that you bring to the class. So, but till we get there, you always have the opportunity to ask me questions. But anything about anything we've done up to this point before we close today?
I got a question, Professor.
Yes, sir.
Negative exponents.
Mm-hmm.
Are you gonna touch on that Wednesday?
No, that's not what's coming up. But do you have a question about negative exponents?
But in the homework, when you do the
Uh-huh.
homework, it touches on negative exponents.
Bring a question to class so we can do it next class.
All right.
I'll see what you're talking about.
Okay.
Yeah, well, because I don't have a problem talking about it, but in these examples, I don't think it comes up. I don't think. So yeah, just bring one for me. We'll knock it out.
All right.
All right. Thank you, sir.
Thank you.
All right, everybody, you have a great day, and I'll see you on Wednesday.
All right, Mr. Parker, take it easy.
All right, take care.
Thank you.
All right, thank you.
Thank you.
All right, thank you. You have a good one.